Hello and welcome back to Blackbird. This is Venkat, and in this video, we will be talking about inheritance. Let us talk about the agenda of this session, which is learning about the basics of inheritance and how to inherit classes, the uses of keywords super and this. This is a reference keyword basically, and super is not Superman. We'll learn about it. What is the effect of final keyword? Talking about method overriding and how exactly overridden methods are decided at runtime by the JVM. We'll talk about that, which is dynamic method dispatch. We'll talk about the types of relationships that exist. This is not an average love relationship. And there are also we'll learn about composition, aggregation, and association. So let's move forward with this. Let's begin with the basics of inheritance and what inheritance actually is. Talking about inheritance, it's basically one of the cornerstones of object oriented programming, where one class can extend the features of the other class. Now, inheritance is defined by is a relationship. Many books specify this, some books jump over from this concept. Using inheritance, you can create a general class that defines common traits to a set of related objects. And then that class can be inherited by other more appropriate classes, which keep adding unique features to it. So basically, there are two classes here in play. One is a superclass. People also love to call this as parent class. Now, this superclass, it is the class from which properties are inherited or properties are taken from. Now, there is another terminology which is a subclass or a child class, and it is the class which inherits the properties from the superclass. But these terminologies are really difficult to understand. A much simpler example would be like this. Let's say this is a parent class with the name of the class being parent, and this parent class, there is another class as a child class which extends this parent class. So basically, this child class extends the parent class. So whatever properties, whatever variables, methods are present in the parent class, that is inherited by the child class and is also present here in this child class. The easiest example of this would be that your parent has some house property, and you as their child would basically inherit this property from them after your parents turn old. So this home property is currently present inside of the parent class, and this person who is going to inherit this property is basically the child. And this exactly is what inheritance is about. Now in Java, inheritance can happen in this way. Let's just write down the example that we took in a code format. So let's say I have a class parent, and and the parent has a property which is protected. Not everyone can access it, which is protected final string property is equals, and then I specify some property number, property 1, let's say. Okay, let's keep it till this one. Here in the parent class, side by side, we'll have a child class, and this child class will have the access to this parent class. So what we'll say, class child extends parent, and if here in this child class, let's say we have the main method, and we try to print the property, this particular variable property from the parent class, what we have to write is simply property. So basically, this is the subclass that you are seeing, and this particular class here is the superclass. Did you know that inheritance is something which is in the core of Java programming language? Why? Why did I say that? It's because there is a class named object. It's present in the java.lang package, and this object class is the superclass of all other classes in Java. So there is a sort of hierarchy that we talk about. That particular hierarchy goes in this way. There is this object class at the very top, which is inherited by basically all the classes that you create or they exist in the programming language. And then there are divisions like throwable and like parent class that we just created, which is a user defined class, and even a child class. So this hierarchy is an example of inheritance implemented within the Java language as its specification. Now you might notice that I have used this keyword protected. What is the use of this keyword, this protected keyword? Let us talk about the member access in inheritance. So we already know about access specifiers, don't we? So we already talked about access specifiers, but here it's important to again enumerate on them so as to understand what is the access level for different access specifiers. So what I'm going to do is I'm going to name down all the access specifiers one by one. So first is the package private, which is when you don't specify any kind of access specifiers. Then there is public, then there is private, then there is protected, and yeah, I mean there are only four types of access specifiers that you can come to know about. Now here are some places. Let's say that I have a class with the name parent, which is a superclass. Okay, and I have another class named child, which is a subclass. Now this parent superclass can be present within the package in which child class exists. It can be present in a different package from where actually child class exists. So we'll talk about 2 to 3 scenarios here. We'll talk about same package. We'll talk about different package, and then we'll analyze what would be the effect if the child class inherits the properties and behavior of the parent class. What would be the effect if that particular property, that particular instance variable, or that particular instance method is specified with these kind of access specifiers? So within the same package, if it's a package private access specifier that a property or a instance variable has been declared with, then even if you don't extend, it will be accessible in the child class. If it's public, again, it'll be accessible. If it's private, it won't be. And if it's protected, it will be accessible. In case of a different package, package private, which means default, the change of packages alters the access when you don't specify any kind of access specifier. So even if you inherit, you won't be able to access a field or a method which is where there is no declaration of any kind of access specifier. Although, if it is public, you can still access it. Again, if it's private, you cannot. And if it's protected, only in this case you can access the properties and methods present in the parent class inside of a child class. This member access is really important when you actually write a program where there is things to deal with inheritance. Private members remain private to their class. You cannot even access it even if both the classes are in the same package. Although we didn't talk about the syntax of inheritance in Java, it is pretty easy to understand it just with the example that I had given to you in the previous slide. You have a class, superclass, and there are instance variables and instance methods. Then you have another class, which is the subclass, which extends the superclass, and then you can access all the instance variables and instance methods that are present in the superclass and are not declared with the access specifier private. Although there is an exception in this case. No superclass can inherit itself. And let me make this clear, just not for superclass, but no class can inherit itself. It means you cannot write class parent extends parent. That's not meaningful. And this is the reason why you cannot write it. A major advantage of inheritance is that once you have created a superclass that defines, some common set of attributes for a bunch of objects, it can be used to create any number of specific subclasses. And each subclass can, precisely tailor its own classifications. It can create its own unique properties and behaviors apart from what it is inheriting from the parent class. Let us now actually do some practical and understand the basics of inheritance. For this, I'll come back to IntelliJ if I have it open. Let me create a package here and a class. I'll say inheritance dot let me say parent. Okay. Within this parent class, what I'm going to do is I'm going to have two fields here. One declared with a protected keyword, protected final string property, which stores parent property in semicolon. And I'll have a private string which basically returns parent hard. Okay. Now if I create a child class here, within this child class, what I'm trying to do is I'll try to extend it to the parent class. Okay. So now let's say that I have a class child extends parent. Okay. And let's say I have a method here, public void to staff, and within this method I'll try to print the property that was brought about from the parent class. Okay. And let's say that I have a main method and I try to instantiate this child class and call the do stuff method. Upon execution, what you'll get to see is that the parent property is getting printed to the console. But you can very well see that we don't have any kind of variable named property within this child class. Where does it get this from? This property is being inherited from the parent class. And this is what we call basic inheritance in Java. But now let's say that you grow up and you see it is already printed parent property. Now let's say that you have actually grown up and you have some other property. So, which is protected final string property is equals child's property. So, you buy your own flat and all, bungalow. I don't know how rich you are, but still. And then, I want to change the name of this get property. And now let's say that, I want to get the property which the parent has. I want to print both of these properties. But how will I do that? How will I print both of these properties? Right now, if I hover on it, I see that this property refers to the child's property here, which comes from inheritance.child. The child class. But I want to print the parent property first. In that case, what Java does is it uses a keyword super. Now, usage of this keyword super is just to refer to the superclass variables, instance variables, or protected variables which are there in the superclass. not just variables but also methods and any other member present in the parent class. And now let's say that, I want to specifically mean which property I'm trying to print here as well. I'll say this dot property. So the use of super and this keyword is applicable in this context. Now if we try to run the program, what we'll see is it first prints parent property and then it prints child's property. So basically in the first print statement, we are referring to the property present in the parent class here. And the second print statement, we are referring to the property variable that is present here, which is in the child class. So let me come back to the PowerPoint and let me write this down. So the keyword super, it has got two uses. The first use, it is used to refer to the parent class members. Now this members can include instance variables, instance methods, and whatever. The other use of super that we'll be studying is it is used to invoke the parent class constructor. So we'll come to this particular thing to call the superclass constructors, but after a while. Let us first discuss and create a constructor in the parent class. Let's say I have a constructor public parent and this prints default parent constructor. Now let's say I have another constructor protected parent which has a parameter of string name, and this particular thing prints parent name, the name of the parent. Okay, now let's go back to the child class and let's say that I want to have a constructor here public child, and what I want to do is I want to print the name of the parent, but before that I actually need to create a field here named private string name. Okay, and after getting the name I want to store it into this dot name is name. We have already learned about this in the previous video, so if you're confused go and refer to that particular video. And what I'll do is I want to get back this name parent name and I'll return this dot name. Works or seems all good. Let's go back here. Now let us say that let us say that when I instantiate this child class, I want to have the access to its parent's name, or I just want to display the name of this parent, of this child's parent. Okay, so what I'll do is I'll try to print super dot get parent name. Looks all good. Let us try and print this out. When we print this, okay, let me just omit this property method right now. When we print this, we get two messages. We first get default parent constructor and then we get a message null. Why did this happen? We just can see one print statement applicable at this point. The get property method is also omitted, it's commented. So where did that second print statement come from? It comes from the parent class. Now let us go back to the presentation for a while. So there is a parent. Oops. Yeah, there is a parent, there is a child. Now there are constructors that are present in the child. There is a default constructor. Okay. And here in the parent, we have two constructors, which is simply a parent, and then there is another one which is a parent constructor with a string parameter. Now when I have extended the parent when I extend the child class to the parent class, cut. Now when I actually extend the parent class to the child class, okay, what happens is this constructor gets called first. Okay, let me just number this down with the execution order. So right after we instantiate it, this constructor gets called first, the child constructor, and before executing any statements within this child constructor, the flow of control goes to the parent constructor. So this particular constructor, the default constructor, which is the parent constructor, gets called first. It gets executed first. Then the child constructor gets executed. And that is the reason why we are seeing that default parent constructor message is getting printed first, and then there is the name of the parent which is getting displayed as null. Now, why is it null? Let us discuss now. Now, when you have instantiated the child class, it's all right. It's all right, but anywhere in the code, you cannot find a place where you actually told the child its parent's name, and that is done by super and then specifying the name of the particular parent. So let me not do this here. This is a default constructor. Let me do it here. Public child with a string name parameter, and then I'll pass this name to the parent constructor. And after that, I'll try to access the name of the parent. Here, when we actually instantiate the child class, I'll name this as let's say Venkat. And now if we try to print, we get a different output, which is parent's name is Venkat, and then we actually get this Venkat printed. So you can see that this particular protected constructor is getting executed at this point, which prints parent name and then the name, which is obviously Venkat. And then here in the child class, we see this particular statement getting executed. A better example to this would be something in this way: child parameterized constructor. And here I'll rather say parent parameterized constructor. Now, if we try to run this, we get this parent parameterized constructor first and then the child parameterized constructor. So basically, any call to the constructor in the child class will first execute the constructor in the parent class, and then it'll come back to the child class to execute the rest of the statements. This notation with the help of super keyword is what we were talking about. It is used to invoke the parent class constructor. The syntax for this is really easy to understand. Let's say that you have this particular constructor in the parent class. So you will use super, and within this pair of round braces, you'll specify the name of the person. What Java will do is it will find a constructor in the super class with the same kind of formal parameter list. Okay, this is the use of super keyword. Now let us talk about something really intriguing but very sensible, which is a superclass variable can store a subclass object. How is this possible? Let us talk about it here. So in the main method, what I'll do is I already have a child. I'll instantiate a parent is equals new parent, and here I'll specify the name Venkat. Okay. Now what I'll do is I'll write parent is equals child. How can I write that? How can a parent be equal to child? Well, no, you are getting it wrong at this point. When we actually write parent is equals child, what is the type of child? Specifically speaking, since the child extends the parent, so a child is a parent, is of a parent type. Note that I'm giving stress on the word is a. So when we actually extend this child class to parent, we say child is a parent. Now look at this again. What do you see? You still see parent is equals child, right? I know. I know that you're not blind. But what the compiler sees is the child is of parent type. And what I'm doing is I'm assigning the parent type to the parent type, to the parent class. Instead of this, if I write parent and then I change the variable parent to, so basically I can ignore all of it and I can write a new child, let's say XYZ. Okay. So basically, this child is a parent, and that is why a parent class can store the reference to a subclass of itself. I mean, to of it. Understanding this is important because this will help you in a lot of ways ahead in programming. A lot of ways. But what if I say that, I want to access this get property method present in the child class, and I access it? So I'll write parent2.get property. Why am I getting an error? This is because when you're specifying the type, the destination type to be parent, you can only access members from that parent class which are common to the child class. You can access only those attributes which are present in the parent class and which are also accessible to the child class. So if I try to say parent2.get parent name, and if I try to print this, simply say, and if I execute this, what I get is XYZ. Okay, there is a lot of hodgepodge that has happened here, parent constructor, child constructor, and all. So I'll choose to omit all of this for some point, and then I'll execute this again. So you see that we get a call to XYZ. Again, ignore this parent parameterized constructor, child parameterized constructor, because we are basically invoking the parameterized constructor present in the child class, which again is passing this particular name attribute to the parent class, invoking this parent class constructor. And that is why you get these two statements. But afterwards, if you actually see that, the name of the parent is XYZ, this is the output. You might have a question that, can vice versa happen? Can I say child child is equals new parent? And if I try to access it, it is not possible. Why? This is the reason. Because the required type is child. The destination type is a child class. But what you're providing with is a parent class. And that is why it's not possible. Although there can be casting here at this point, but even if we try to run this, we get an exception, which is class cast exception. Let us see this error. Class inheritance.parent cannot be cast to class inheritance.child. This class cast exception happens in this case, so be careful. Even if you typecast, it won't work. All right. Now let us move on to discussing multi-level hierarchy or the types of inheritance. So what are the type of inheritance? First is a single inheritance where there is a parent-child relationship. Then there is a multi-level inheritance. There is multiple inheritance. There is hierarchical inheritance. And then there is a hybrid inheritance. In case of a single inheritance, the examples that we had seen in the previous slides, that is the case of um, single level inheritance. Talking about multi-level inheritance, before actually getting into it, I want to discuss about the inheritance tree because this will be really important for us. There are some symbols and notations that you need to understand. If there is a arrow symbol like this, and there is a class, let's say A, and there is another class to which the arrow is pointed to B, this is equivalent to A extends B, where A is the subclass and B is the superclass. Now, what is the deal here? Object class is the topmost in hierarchy. Below that, I mean, every class actually inherits the object class. Then we have a class, let's say named C, which is inherited by the class B, and which is again inherited by the class A. So this is the grandchild class. This is the child class with reference to class C, and this is the parent class. So A extends B, B extends C. That is what it means. And this particular hierarchy is actually what we call as multi-level hierarchy. Just the same way as single inheritance happens, if you have a constructor, let's say constructor A, and then you have actually a constructor B, where basically you have a print statement which prints A constructor, and here again in the B you have B constructor, and then here in the C class you have C constructor. Okay, now if you actually instantiate this class A, so let's say I'm writing A obj is equals new A, the call will come to the parent constructor first. So what will be the printing hierarchy? We first call the A constructor. This constructor goes to B because basically A extends B. B's constructor again goes to C because it sees that B extends C. This particular statement is printed. So in the output window, it looks something like this. C constructor. Then the execution goes back to B. It prints B constructor. And then it comes to A, where it prints A constructor. This is what we call multi-level inheritance. Let us talk about other types of inheritance in Java. Single is possible, multi-level is possible, multiple is not possible but is implemented via interfaces. So basically you can implement a lot of interfaces in the same class. We'll talk about that in the next video. Then there is a hierarchical inheritance, which basically means that there is a super class, let's say A, and then there are multiple classes which basically inherit this A class, let's say B, C, and D. So this is also possible. Hybrid inheritance is somewhat possible in Java. If a hybrid inheritance does not contain a multiple inheritance, then it is possible. But then again, you won't need hybrid inheritance in any kind of programs, as far as I remember. Okay. There is something related to method overriding that we should talk about. What is method overriding? Where does this term comes from? Well, this term actually came from runtime polymorphism. So you see, one of the major concepts of object-oriented programming, which is inheritance, comes from runtime polymorphism, which is again another cornerstone of object-oriented programming. So in a class hierarchy, when you actually need a method in a subclass that has the same name and type signature as the method in its superclass, then the method in the subclass is set to override the method in the superclass. Better to write this down. What did I say? When a method in subclass has same name and signature, there is something known as method signature that you should know about, as the superclass method, we call it method overriding. So this is what method overriding is. Let me give you a really strong example for this. We'll use the same example, the parent class, but with a slight change. This parent class has a method get property, okay, which prints the parent property name. There is the child class where we already have this method get property, okay, which tries to print the property that the child has. So let's make the changes, required changes in the code. We are in the child class at this point. I don't need all of this constructors and all. I have a public void get property which prints this dot property. Good enough. And let me come to parent class. Let me remove all of this shit, and then we write get property which returns this dot property. All right, even though it is accessible, it's protected, so it's accessible in the child class. I still want to have this get property method here in the parent class. Now here definitely I cannot have like this. I have to return something which is I'll write return this dot property. So I'll write, and I'll change this void to string, remove all of this shit, clear away the blank spaces. Our code looks good now. Now what I want to do is instantiate a child. Let's say child is equals a new child, and then I print child.getProperty. Now I also instantiate a parent is equals new parent, and then I try to print parent.getProperty. So now let us execute this and actually see if they are working or not. Yes, first we get this particular thing executed, which is child's property, and then the next one, which is parent's property in this line 17. Now let me do one thing. I have this parent, and I'll assign this child subclass reference to the parent, and then I'll again try to print this. Let's see what we get. It prints the child's property. How is it possible? It is because of overriding. There is a concept which we call as dynamic method dispatch. It is a mechanism by which a call to an overridden method is resolved at runtime than on the compile time. So if I were to write this definition of what I said, let me write it. It is a mechanism which determines what version of overridden method to invoke at runtime rather than compile time. So there is a really big difference between dynamic method dispatch, method overriding, and method overloading. Overloaded methods are the version of those overloaded methods is defined at the compile time before you actually execute the program. But a call to overridden method is determined by this particular mechanism in the JVM, which is a dynamic method dispatch. Let's come back to our code. You see, we actually instantiated a child class. It prints the child's property here. Then we again have a parent class instantiated. And we get the parent property. Now we assign the subclass reference, which is the child, to a superclass variable, which is parent. And then we try to print parent.getProperty. This prints the child's property just because what the JVM sees at runtime that this particular parent holds a child reference. And since there is a overridden version of the get property method, we basically get child.getProperty. We basically get child property. A better way to understand that a particular method is overridden or not, we use the override annotation. And then you can see there is this small symbol, which means that this method is also present in the parent class. And if you see, it is actually present. And when you execute this particular statement, you get child's property. So when a overridden method is called through a superclass reference, Java determines which version of the method is basically actually to be executed based upon the type of object that that particular reference is referring to. But you might have a question that why exactly do we want to override methods when we obviously have an option of overloading them? The simple answer to this lies in the fact uh, normal, like a general class to specify methods common to all its derivatives. And this is why method overriding gets really interesting. There are another way that you can implement overridden methods. Like it comes under polymorphism, but then again, since it's an inheritance topic, we can discuss it. Overridden methods are another way that Java implements the one interface, multiple methods aspect of polymorphism. Understanding the superclasses and subclasses hierarchy makes you move from lesser to greater specialization. You have a parent class which might be partially implemented, and then there is a child class which is fully implemented. So we call the child class to be a concrete class and the parent class to be an abstract class. Runtime polymorphisms is one of the most important mechanisms of object oriented designs because it It is the single thing that bears the code reuse and robustness um, thingy in a programming language. So the ability of an existing code library is to call methods on instances of newer classes without recompiling or without having the pain to maintain a clean abstract interface is something really powerful that Java offers. And this is why you should override methods if and when needed. You don't do that unnecessarily. We'll stop our video here and we'll discuss about abstract classes, interfaces, usage of final keyword, and the object class in this inheritance part 2 video. So thanks for watching this video. We'll be off till here. Goodbye.